In this video, we'll talk about inverse and converse, what they mean logically, and we'll talk about their logical structure. So if we consider a standard logical statement where H implies C, some hypothesis implies some conclusion, if H then C, however you prefer to think about it, our standard hypothesis looks like this. So if we look at the inverse, what this means is that I'm going to rewrite the statement as not H implies not C. We're just simply negating both the H and the C. That's what the not means. So like for instance, if the hypothesis here was x equal 4 and the conclusion for the original was x squared equals 16. Well, in this case, it's pretty easy to negate these. We can say, okay, if x does not equal 4, this means x squared does not equal 16, which we know this to be false, because what if x is negative 4? Then it meets the hypothesis, but it is equal to 16 when I square it, which would fail to meet the conclusion of not being 16. So it's worth noting the inverse is not always logically equivalent. I guess I should just say it's not logically equivalent. So if we consider now the converse, so converse is rewriting it as C implies H, so essentially writing it backwards. So if we go back to our example, we'd be saying x squared equals 16 implies that x equals 4. Now again, we know this to be false because what if x is negative 4? Then x squared would indeed equal 16. I would meet the new hypothesis, which was my old conclusion, but I would fail to meet the new conclusion, or the old hypothesis. X would be 4 or negative 4, which is not 4. So again, this one ends up being false, where the original, I think, ends up being true. So again, with the converse, it's worth noting they're not logically equivalent to the original statement. Now, sometimes it's important to think about structure, and it's very important to talk about these because they are very close to the contrapositive. And if we try to prove the inverse of the converse, we may not be proving the exact same thing. It may not be a logically equivalent statement, and therefore our proof would be invalid. However, it's important to talk about the structure to really play with the building blocks of logic.